Greetings, the Astro 30 here yet again. I'm trying something different with the camera. I've got the tripod extended a little bit higher on the desk rather than at like 600mm away from where I'm looking at on the desk here. We're more like a meter away, so it might help with the focal issues with the camera I sometimes have when dealing with close-ups on PCBs. Speaking of which, I've got a set of PCBs here and it's for a project that's on Elliott Sound Products website, project number 3, which is this old faithful 60W amplifier that he designed well back in the 70s. And he said, and I quote, that he does not recommend building it. However, I'm going to anyway. So I've had the PCBs already made, and you're probably wondering, why would I do that without testing the circuit first? Well, when I can find my scissors, that'd be great. I've built the second version on that particular page, and I'll link that in the description so you can look at it, which only had a couple of modifications to the original circuit. It removed a Xeno diode and it added a biased servo. And I'm having trouble locating my scissors because they seem to have disappeared. Oh, there they are. And I have actually built that one and it works. So I'll just open the bag because the rest of the circuit is based on the first version anyway, so there's hardly any differences between the two. Alright, so there we go there. That was harder than necessary. So this is the PCB, and it's a little bit different to my normal PCBs where I have, you know, my little logo on there and more text than that. But I kept it simple because it's only a test PCB and that's the bottom of it. Got some nice thick copper traces here for the power rails and the output, which is between here. And yeah, I'm planning on doing a few tests. What I want to know is how well this performs into 4 ohms, how it performs into 8 ohms obviously, but the reason I want to do it into 4 ohms is because I want to actually bridge 2 of these modules together to almost quadruple the power output. So we'll be looking at close to a 200W amplifier on a plus minus 35V supply rail. That's the whole entire point. However, I've got most of the components. I have to go out and buy a TIP36C because I don't have one, but I've got plenty of the TIP35Cs, other way around. And just build it, test it, and it'll be a good test on my new built power amplifier power supply unit that I built the other day. I've also got some other PCBs to explore, but one of them is wrong, so I'm going to have them remanufactured, but that'll be in a future video, not in this one. So I've designed it so that the transistors mount flat and we put a bracket here. So let me grab the bracket. So I got this piece of scrap aluminium offcut from that AEL 480 project that I made the heatsink brackets for. And yes, it's going to probably cover the text of 60W power amplifier, but that was not really that necessary. So I'm not going to cut this down, I'm going to leave it at its current length. And all that will allow me to do is just to bolt the transistors to the bracket and then just clip this to a heatsink, because you should never run a power amplifier, even for a short period of time for testing, without a heatsink. Sitting idle, this piece of aluminium bracket would probably be sufficient enough to dissipate any heat as long as there's no thermal runaway conditions. So I'm not going to show the schematic in the video because it's intellectual property owned by Elliott, so I'll just link that in the description as I said, and you can go check the schematic out. I'm basing this on figure 1 in that article. So what I'm going to need to do now is I need to go out and buy a few components. I need some 22 microfarad 63 volt capacitors. I've got a 1 microfarad knocking about somewhere. Fuse holders and some fuses because I don't have any 3 amp fuses. And for the input I'm just going to use a PCB pin rather than the socket, as long as the ground for the input is over this ground here. And yeah, build it up. So let's get cracking. Right, I've got the parts I need to assemble this power amp, so let's get going on that. So I'm going to do a time lapse, but I will mention one thing about this. I don't know if I did in the intro, I can't remember. There's a diode that goes under these two 5-watt resistor devices here, right there. So you'd have to put the diode in first before the resistors. So I do all the low profile resistors first and the diodes, and then finally the larger resistors. Alright, let's get going. There's the board assembled there apart from the output stage, because I've got to drill the holes in the bracket first. Yeah, it turned out reasonably well, I guess. Now that capacitor is awfully close to this ground lug, so it might make putting a crimp female on there a little bit more challenging, but yeah, it'll do. Alright, let's get that heatsink bracket drilled so I can complete the output stage and then begin testing this. Right, the bracket is done, transistors are soldered in. Yes, they're different cases, but that's alright. It's attached to a heatsink. Never test an amplifier without a heatsink, even for a short period of time. Right, I'm going to use my bench supply set at plus minus 12 volts to start with, and the multimeter is connected to the output. So if I turn the load on, okay, so I'm going to increase the voltage on both sides, and hopefully that output offset will come down. Right, well, that's not very helpful, is it? So I'm going to use my newly built power supply. I've got the fuses removed and two 100 ohm safety resistors across the fuse holders. And the multimeter is still across the output. I probably should use the dim bulb first. Alright, that's sort of that. Let's see what happens. Absolutely nothing. There's 15 volt DC across the output. Which is odd to say the least. There shouldn't be. Well, that's annoying. So that little module was a complete fail. Shit. Alright, I found the issue. The 560 ohm resistor in the long tail pair collectors is too small of a value for, well, the supply voltage I've got, but it could also be the dim bulb affecting it. But I've put a pot in series with the 560 ohm resistor and just a little tweak and the DC offset came right down. So you can look at the meter. I'll turn the thing on and we've got about minus 20 odd millivolt there on the output, which is perfectly acceptable. So if I adjust this pot all the way back to 0, see we've got 14 volts there. Just a slight increase and it's 78, a little bit further and I can make it less. Dim bulb gone, now they know it's safe to operate directly off the mains supply. I'll just turn it back on. Nothing exploded, that's always good. Now I'll adjust that pot again and see what happens. Yeah, the resistor value is too low. So I'm going to have to play with this. That's what she said. Because if the resistance is too high, well, the DC offset's going to be too high. There we go. 13 odd millivolt. Not bad. 1.5k is where it seems the most happiest at. So that's where I'm going to leave it as. So now back to what I was doing originally is I'm going to run this on the bench supply and see what the minimum voltage is this will operate at. Okay, so plus minus 12 volts roughly. The DC offset's not too bad, it's a bit high. Let's increase voltage to say 15 plus minus. Yeah, it's not too bad. So I want to say that probably the 15 odd volt mark is roughly where it's happy at. Because if I now touch the input, you can see that that jumps around. So it's appearing to work as an amplifier. Well, let's load it and find out. I've just got it going into the load first. Just want to see if anything weird happens with the power supply. Didn't go into current limiting, so alright, that's alright. Alright, got it into the scope with an input signal. Okay. I reckon I've got an earthing issue here. Or too low a voltage. It also looks like it's oscillating. Much better. It was a grounding issue. Let's give it some gain. Okay, not bad. At plus minus 15 volt, we're getting roughly 26 odd volt peak to peak. Current draw is close to 500 mA, because I prefer to do these tests on a bench supply, because I can then just, you know, verify if anything's going to overheat. And it's also the voltage is lower. That's actually 10.5 watts RMS at that voltage, plus minus 15 volt. That's not bad. Alright, so I'm going to reduce the voltage even further until it just stops functioning altogether. I'll have to drop the input. So we're starting to oscillate at the 12 volt mark. So I'm going to say that 14 volts is the lowest this will operate. That's plus minus 14 volt. So I'm going to let that run for a bit. Drivers are starting to warm. Bass is okay. And yeah, just see if we go into thermal runaway. Right, that operated alright. So I'm back on the other supply now. I'll drop the volume right down. Yes, we still have an output. Nice. I don't want to give it too much power because I don't want to blow the fuses in the supply. Oh, 17.1 volt RMS before clipping, which puts it at 36.5 watt. Okay, not bad. Now let's see if it's stable into a 4 ohm load. Okay, it's now into 4 ohms. Hopefully nothing goes up with a bang. No, and it does produce a signal. 14.7 volt, which is 54 watts RMS into 4 ohms. Yeah, okay, with a slightly higher power supply that figure will be a lot higher. Very, very good. So, I suppose I should hook up a speaker and see what it does. I'll use one of those crap TX speakers I don't care about. Speaker's connected, and hopefully nothing strange comes out of it. So, I've got to be careful. There's no short circuit protection on this module, so if you short the output leads, bye-bye output stage. A slight pop, nothing unusual. Amp it up. It's going to explode! Nice. Pop. Let's see how it sounds with some music. Here we go. Excellent. So I'll try an online sweep generator just to see how that sounds, and I will probably put it back on the scope and have a look at its frequency response. Going from 1 Hertz to 22 kilohertz. There was a slight hum behind the speaker too. That's most likely because of the leads and the power supply itself. So let's do that sweep test again. Okay, I got no output. I had to turn the gain on the scope up. There we go. It's looking reasonably flat. Still at the 2.2 volt RMS mark. It's actually gone up a little bit. But no, it's looking reasonably flat. We're at 10 kilohertz now. It's not appearing to roll off anytime soon. Starting to drop in voltage now. We're at 15 kilohertz. Still remaining quite steady in its output voltage though. No, it's not really dropping off that much. 17 kilohertz, which is now beyond most audible hearing range anyway. 18, still at 2.25 millivolts. Now it's starting to roll off at the 19 kilohertz mark. 20 kilohertz rolling right off. And 22 almost non-existent. That could also be the computer's output as well. Well, I'm happy with that. Turned out alright, even though we had a slight issue to start with, but I figured the problem out. So yeah, that worked out wonderful. Nothing's getting overly hot, which is good. So I'm going to leave this video here. If you enjoyed it, please remember to go down below, like, comment and subscribe if you haven't done so already. And this is the Astro 30 saying, see ya, have a great day.